How expensive do you think a rocket is? Specifically, NASA's main rocket system for their Artemis program, the Space Launch System, or SLS for short. How much do you think it costs to launch the SLS once? A few million, tens of millions, hundreds of millions? Let's see what other people guessed. Most people guessed in the ballpark of $100 million to $1 billion, while the second most category is $1 billion to $10 billion. Now, here's the actual answer taken directly from NASA's 2024 budget request, $4.5 billion. Now, this said, what do you think NASA's budget is? A few $100 billion, right? Something high to make launching the SLS worth it, right? Wrong. NASA gets around $27 billion annually from the United States federal government. When you take into account the cost of the SLS training astronauts and other experimental tech NASA works on, you start to realize why they only launch the SLS maybe once a year maximum. Now, how much do you think it costs to launch SpaceX's reusable Starship rockets? Once again, let's see what other people guessed. Most people guessed $100 million to $1 billion again. However, believe it or not, this is quite an overshoot. The actual answer is around $40 million. Much cheaper, right? Well, it's actually about 99% cheaper. How could this possibly be the case? The answer, at least partially, has to do with rocket reusability. SpaceX is a prime example of the power of utilizing rocket reusability technology. Reusing a rocket, say, 10 times leads to a huge reduction in costs compared to launching and disposing of rockets 10 times. Think about it. You could save on the raw materials and manufacturing costs. This seems great, right? Well, it isn't all sunshine and rainbows for rocket reusability. NASA is a key example of one of the counter-arguments to rocket reusability, and they have their own previous data to back up their claims. That's right. NASA has already experimented with reusable rocketry before, the Space Shuttle. The Space Shuttle was a mostly reusable system. The shuttle would fly up attached to a main external fuel tank, the big orange one, and attached to that were two solid rocket boosters. Everything was reused in the shuttle program aside from the main external fuel tank. One would expect this reusability to greatly diminish costs of launching the space shuttle. However, it did not. To understand why NASA's shuttle program still costs billions of dollars per launch would lead us to understand one of the key drawbacks to rocket reusability. The key way that reusability lowers costs is by allowing for more launches on the same hardware. That is, more launches with the same rocket means less is spent on manufacturing. This is where NASA's space shuttle program was flawed. It only launched about 4 times a year. Also, the space shuttle was a very complicated system compared to more traditional rocket systems. For example, the space shuttle contains significantly more heat shielding than any other reentry capsules. This is due to the surface area on the bottom of the shuttle being much larger than that of traditional reentry stages. This led to increased costs and time spent on maintenance of the shuttle between flights, as every single tile had to be inspected. Even one faulty heat shield tile would lead to catastrophic failures upon reentry. In the end, the space shuttle was just too expensive to maintain due to certain engineering choices, and it was not launched enough to justify further reusability. Furthermore, reusable rocketry is an immensely complicated system to develop. It took SpaceX 15 years to land a stage of one of their rockets, and that's considering that SpaceX's whole goal was to develop reusable rocketry. They didn't have any other responsibilities like NASA. The engineers at SpaceX often worked overtime to try and develop these systems. If it took SpaceX 15 years to develop this tech, imagine how long it would take NASA, an agency that focuses on more than just rockets, to develop the same systems. And it is more than just time as well. Reusable rockets are an engineering nightmare. They are extremely complicated. Developing a very complicated system has 2 huge drawbacks: having more failure nodes and being extremely expensive to actually develop. SpaceX's success is due to one engineering principle. They utilize rapid prototyping. Rapid prototyping is essentially the idea of creating tons of prototypes and observing what fails. This is a more learning by doing approach, and it works way faster than spending years trying to make a perfect system without observing what can go wrong. This is akin to doing practice problems before your calculus exam as opposed to just reading the textbook several times. NASA just has too much on its plate to mess with rapid prototyping. SpaceX quite literally has nothing to lose with its unmanned missions, but NASA bears the responsibility of, for example, the ISS. With so much of NASA's budget going towards maintaining the ISS and other research projects, remember, NASA is more than just rocketry, it also does air-based vehicle research. When NASA does actually launch a mission, it can only afford to do so once and successfully. There simply is no room to conduct rapid prototyping. Now, you may be thinking, if reusable rocketry is such a good investment, why doesn't NASA just relocate its budget? The answer to this question goes back to the 1960s with the space race. The space race was a very tense time for NASA. They were attempting to beat the Russians in landing a human on the moon. The informal motto back then was to waste anything but time. This mindset snowballed into what we see today with the SLS. Spend less time on development and waste more resources. Note that the SLS did take a long time to develop. It's just that if NASA decided to make a reusable system, it would have taken more time. A paper I read dubbed this effect Apolloism. Essentially, NASA has a business model that, while being inefficient, works well for them. Relocating the budget to develop reusable rocketry tech would mean very little would get done in other sectors for several years. Furthermore, what makes reusable rocketry so cheap is the fact that the same rocket can be launched several times over in quick succession. With NASA's current launch rate, they wouldn't benefit much from this model. However, just because NASA can't develop reusable rocketry doesn't mean it is a totally hopeless field. Since the private sector is making significant progress on reusable tech, NASA can just wait and use what the private sector develops. This is why NASA has several contracts with private companies to develop, like SpaceX. This would allow for NASA to continue to focus on their current missions without spending a fortune on directly developing reusable rocketry. Now, what exactly are some of the benefits of reusable rocketry aside from being several magnitudes cheaper than their non-reusable counterparts? Let's start by looking at another aerospace industry that benefits from mass reusability, the airline industry. Try to imagine how expensive the airline industry would be if planes were discarded after each flight. Now, that doesn't sound very sustainable, does it? For commercial flyers, the ticket price would be well out of most people's budgets. Conversely, imagine how much cheaper a ticket to space would be if rockets were reused. Lowering prices means increasing accessibility, which means more demand. More companies wanting to launch payloads on rockets means that the industry would likely be forced to grow. This is simple economics, and a larger industry could drive research for more advanced tech, spearheading the way back to the moon or even to Mars. Growth of the space industry even has some cyclical aspects when it comes into contact with the tech market. For example, asteroid mining. While on Earth, we have to drill several miles down at times to get into veins of minerals, asteroids can contain massive amounts of precious minerals right on their surfaces. In some cases, asteroids are even the ejected cores of planets, and planet cores are typically made up of heavier elements like iron. Harvesting the iron from an asteroid that is nearly 100% iron would lead to an astronomical profit. And it's more than just iron. Gold, platinum, copper, and so on can all be found on asteroids. These materials could be used to lower the price of technology that is currently limited by the price of metals. A lowered cost of raw materials would lead to being able to put more resources into technological development. Thus, an influx of raw materials could lead to technological advancement. This technological advancement could be used to further the aerospace industry. Additionally, technological advancement could lead to novel solutions to some of the most pressing issues here on Earth. For example, cheaper metals would mean that heavy-duty machinery would be easier to produce. This machinery could be used to drill wells, build homes, maintain farms, and so on. We don't necessarily need to keep our heads constantly in the stars with reusable rocketry. There's also a less traditional usage of reusable rocket tech, Earth-to-Earth transportation. Our current airliners can get you anywhere in the world in about a day. Rockets could accomplish this task in a mere half an hour. This would be revolutionary for consumer transport and shipping. Reusable rockets are the way to a more advanced civilization, and it may be possible within our lifetimes.